Good morning, everybody. We're going to go ahead and take a quick look at your homework from yesterday. You had those three problems. There was two typos in the directions. One, the direction said find the measure, not find the measure. But also, you weren't actually supposed to find the measure of the angles as much as you're supposed to find the value of the variables. And then it said and justify each step. So it is what we did in class. The directions were written a little bit wrong. Hopefully you still did the right thing. Either way, we're going to dive right into it. Number one said angle A and angle B are complementary angles. It then gave the measures of them. So we're supposed to list the statements and justify each step. The very first step, we would say that angle A and angle B are in fact complementary angles. And our reason why? Well, that was given. That was given to us at the beginning of the problem. After that, we'll say that the measure of angle A plus the measure of angle B add up to be 90 degrees. Now, why do they add up to be 90 degrees? Because that's the definition of complementary angles. That's what it means to be complementary angles, two angles whose measures sum 90 degrees. At that point, we're actually kind of done with the geometry. We switch over to algebra. And in place of measure of angle A, what we're going to do is we're going to put this in place of measure of angle A. And in place of measure of angle B, we're going to put that. Okay, and so we're going to just rewrite that previous line. And it's going to say 3x plus 12 plus 2x minus 22 equals 90. And we're allowed to do that because the substitution property of equality says that we can do that. At that point, we can bring things together and combine like terms. And we say 3x plus 2x is 5x. 12 minus 22 is negative 10. All that equals 90. If someone said, well, why are you allowed to do that? All we did was simplify. At this point, we can add 10 to both sides, which makes us say 5x equals 100. That is the addition property of equality. If we add something to one side, we just have to add it to the other side. And lastly, we divide both sides by 5. We get x equals 20. And that is the division property of equality. Okay? And so hopefully everyone, you all got that x is 20, and hopefully you're able to justify your steps along the way the right way. This would be basically the only way that you could have it. I can't think of a different way that you could have done it. And so this is generally what we're looking for. Okay, let's look at the second problem. Second problem is almost identical to the first problem. The only big change is that it's supplementary angles this time. It's not complementary angles. And so, excuse me, that's a small, very small change. But we're going to go ahead and say that angle A and angle B are supplementary angles. And again, that is given information. And we go, well, what does it mean to be supplementary angles? Well, it means that the measure of angle A plus the measure of angle B equal 180 degrees. And that is the definition of supplementary angles. You might have even heard me say just now, what does it mean to be supplementary angles? Well, what does it mean? It means that the two measures add up to be 180. And at that point, just like before, we're kind of done with the geometry at this point. We switch over to algebra, and we say 3x plus 12 plus 2x minus 22 is equal to 180. What says that we're allowed to do that? Well, it was the substitution property of equality. If you have things that are equal to each other, which is what we have up here, then you can swap those things out at any time. All right, and then we're going to say 3x plus 2x is 5x, 12 minus 22 is negative 10. All of that equals 180. All we did there was simplify. We can add 10 to both sides, which gets us 5x equals 190. And that is the addition property of equality. Why is it the addition property of equality? Because we added 10 to both sides. And lastly, we get x is equal to 38. Why is x equal to 38? What made us go from the previous step to that step? The division property of equality. We divided both sides by 5. All right, and then the last problem is just a little bit different, not drastic, but just a little bit different. It says that these are vertical angles. And if you remember, vertical angles are when we have two intersecting lines. It's the angles opposite of each other. And we had proved that these angles are always congruent. So we're going to start this one and say the same way. We're going to go with the given information, say angle A and angle B are vertical angles, and that's given. And now at this point, we kind of take a slightly different approach. We're going to say that angle A is congruent to angle B. And how do we know they're congruent? That's not the definition of vertical angles. You might think that, but it was actually a theorem, and we proved that theorem to be true. We proved that vertical angles are congruent, that they're always congruent. That was something we did. I said, this is going to be a theorem. A theorem is like a postulate. Postulate is a law that we can't necessarily prove. We just kind of accept. And a theorem is the same kind of law, but we can always prove them to be true. And we proved that vertical angles were congruent. We did that last week. And so now we're looking at this going, okay, so I know that vertical angles are congruent. And then if they are congruent, that would mean that the measure of angle A is equal to the measure of angle B. And again, you may have caught me say, that's what that means. That is the very definition of congruent, or definition of congruent angles. Okay, if you have two angles that are congruent, it means that their measures are equal. Okay, you can't say the angles are equal, but you can say their measures are equal. All right, and then at this point, again, the geometry is kind of all done right now, and we can say 6x minus 22 is equal to 2x plus 22, and that is just the substitution property of equality. We're going to go ahead and subtract 2x from both sides, which gives me 4x minus 22 is equal to 22, and that is the subtraction property of equality. We subtracted 2x from both sides, and at this point I'm going to go ahead and add 22 to both sides, which is going to get me to 4x equals 44, and that is the addition property of equality. And lastly, we'll divide both sides by 4, and we get x is equal to 11, and that is the division property of equality. And you can always double check to see if this answer makes sense by plugging that back in. We could have done that with the other two problems as well. We didn't. And so we could do that with this one and say, hey, does it make sense that x is 11? You go, well, 6 times 11 minus 22, 6 times 11 is 66, minus 22 is 44. And if we think about what's 2 times 11 plus 22, well, that's 22 plus 22, which is 44. And so the fact that we got the same number, we go, that makes sense because we knew that these were vertical angles and they are congruent and their measures are equal. And so it does make sense that x is equal to 11. All right, hopefully that is the answer you got, and that is how you justified it. I can't think of too many different ways to do it, but so this is generally what we're looking for. All right, we're going to do a little bit of practice now, and then we'll try to go over that.